Okay, so we have completed till fractional distillation of a crude oil. Now we are going to start with the next experimental technique, which is chromatography.
PDF आपने शेयर किया है
Hmm. It's shared, right? Okay. So in chromatography, we separate the mixture of a soluble substances using a solvent. So we choose any solvent in which all the components of a mixture are soluble, but all the components doesn't have a same solubility. Their solubility always differ, and due to the difference in their solubilities, the solvent, it gets separated. So the most common application, mostly we use chromatography in food colors, walaikum assalam, in highly colored sweets, in leaf pigments like green leaves and autumn leaves. The color of the leaves are shown by the pigments. So to identify those pigments and the colors in that pigment, then pen inks. So all of these things, the colored things, can be separated through chromatography. After this, we can use amino acids. We can separate amino acids through chromatography as well. Okay, but the only difference is that amino acids are colorless. Okay, so I've shared all of these notes with you guys, so you can copy it from there as well. Okay. Now,
सर अमीनो एसिड्स किस टाइप के हैं?
amino acids are basically the compounds which makes proteins in our bodies. So if there are multiple many amino acids, so if we have to identify,
the presence
yeah, so we will first separate them through chromatography, and then after separating, we will identify. Is this clear? Just give me a moment. Yes. आसान हो जाए। Okay. So. Okay. I will share the link so you guys can watch the whole process. It's not supporting while sharing. Okay, so for example, if you have to perform the chromatography for a plant leaves and you have to, separate the mixture of the pigments which are present in the plant leaf, what we will do, we will first cut or grind the plant leaf. Okay, and after cutting and grinding, we use pestle and mortar. What is pestle and mortar? It is basically used for a grinding. It's a ball, and there is a one uh, stick like this from which we actually grind the leaves. And what we do, we add ethanol in this pestle, a liquid, and a sand. So along with the ethanol, along with the sand, the surface becomes rough and the leaves can be easily grinded. And when the leaves grinded, the pigments which are present in the leaves um, are released and they get dissolved in ethanol. So after this, we will filter the liquid. On filtering, all the grinded leaves and the sand get separated. And in the filtrate, we got the pigments dissolved in the ethanol. Till here, is this clear? Okay. Then what we will do, we use a one paper, normally we call it chromatography paper. In that chromatography paper, we draw a line with a pencil. That is very important. Whenever we are drawing the line, we will draw that line with the pencil. Look over here. And why do we use yeah, that's what I'm going to tell you. See, that's what we do. See, that is the paper. Here, see, a pencil line is drawn, and after that, we apply that extract or the some drop of that solution on this pencil line. Okay. Why would we do not use a pen? It is because if you draw the ink with the pen ink, what will happen later on? It will also get dissolved. So your sample gets contaminated with the pen ink, and you are not able to get the actual components of the mixture. So pencil is of graphite and it doesn't dissolve. So after making the drawing the pencil line, what we will do, we will apply the extract to the paper on a pencil line and then place the paper in solvent. This whole process is asked in paper 2 for 4 or 5 marks, that how to perform the chromatography. So you have to write down these points. Okay. So then place the paper in the solvent with the solvent level below pencil line on paper. That is very important. When you put it in the solvent like this, you have to make sure, for example, see the solvent level is this. So some of the paper is dipping in it, but this line is further away at the top from the solvent. It is also because if it is dipping the solvent, if it's dipping the solvent, so this spot that we have applied dissolves in the solvent, and it drains off the paper. So that's why we keep the solvent level below the pencil line. Is this understandable? Okay. Then after this, we leave it for some time. So what will happen, that solvent starts traveling on the paper, and it's traveling up the paper, and as it crosses that spot, it dissolves the spot along, and the spot also traveling along with the paper, with the solvent. Okay. We wait it till all the solvent travels to the top, where we mark a line. We call that line solvent front. Okay. And after that, we will calculate the RF value. I'm going to tell you RF value. First, look over here. See, it is the initial stage, right? Then after some time, you will observe it like this. See, the whole solvent. No, this is the pencil. And this is some mixture which we want to separate into its components. Yes.
So which type of solvent we use?
Normally we use water or ethanol. There are two types of solvents.
And how do we determine that water?
Normally, examiner tell you what solvent you are using. Otherwise, you can write anyway. Okay. So see, this line is of pencil. So see, it doesn't travels, but the spot that we have placed of a mixture which we want to separate is started traveling with the solvent. And see over here. Now we are getting three colors. So it means that the mixture which we have separated, that mixture have a three components. Is this understandable? Okay, so this is the solvent front, the distance over here. Okay, now how we will calculate this RF value? That is also important. Okay, see over here, that is the first stage, as I have told you. First, baseline is drawn, then a spot is applied. After that, it is placed in the chromatography paper. It is the ongoing process, and at the end we are getting this result. So it means this component have how many solid components this mixture have?
Three विषय component same है.
नहीं, it varies.
तो examiner से कौन सा component आता है?
No, examiner normally show you the diagram. Okay, so if you are getting, instead of these three spots, if you are getting only one spot, what does it mean?
It is an element.
No, it's pure. It's pure. It's not a mixture. Okay, but we can't say it's an element. It's pure, and if we are getting more than one compound, more than one spot, so it's a mixture. Okay. The other thing, if you see here in this experiment, the chromatography is done for the black ink. So after chromatography, we got that there are three dyes, right, which are making black ink. One of these are dye R, dye Q, dye P. Now, if you see, dye P just traveled a very smaller distance, isn't it? And dye Q travels a little larger distance, and the dye R travels the furthest distance. See, so from this, what we can conclude? We can conclude about the solubilities of these dyes in the solvent. The dye which travels most in the solvent, it is the dye which is most soluble in that solvent. And the one which travels smallest is the one which is least soluble in that solvent. Is this understandable? Yes, if anyone have any question, please ask. Yes, Khatija and Aisha, is this clear?
Yes, sir.
Yes, Aisha. Clear? Okay. how you will calculate the RF value? If you look at the formula, sometimes examiner asks you to calculate the RF value. See the formula: distance traveled by the substance over distance traveled by the solvent. So you will use the ruler, and if the spots are like this bigger, so you will mark it from the middle, from the start. So that is the distance traveled by the dye P. And if I have to find the RF factor, retention factor value, RF value for the dye P, I will note this distance. For example, it's 1 centimeter. Then I will measure this distance. For example, it's 12 centimeter. So RF value for this dye will be 1/12. And then whatever the value you got in the fraction, you will note it down. Okay. And then over here, for dye Q, we will note this distance. For example, it's 3, right? Let's suppose. And the whole distance is 12. So the RF value for this will be 3/12. And for example, this distance is, let's say, 11. So RF value would be 11/12. When we got the RF value, actually, why we calculate the RF value? Because we don't know the substance, right? So there is a chart that is provided to us, in which chart there is RF value of so many compounds in that specific solvent. So then we, after calculating this value, we match the value from the chart, and then we identify whose substance value is matching with this one. Is this understandable? Yes. Okay. Now.
Sir, I have a question.
Yes.
सर आई वांट टू आस्क कि ये जो सॉल्वेंट होता है वो बेस लाइन से नीचे क्यों होता है? कैन यू प्लीज टेल दिस अगेन?
आपकी आवाज बहुत स्लो हो गई है, कैन यू रिपीट?
सर ये जो सॉल्वेंट होता है बेस लाइन से नीचे क्यों होता है?
ओके, इट इज बेस लाइन से, अगर फॉर एग्जांपल if this is baseline and we have spotted place the spot over here, right? अगर जो है आपके सॉल्वेंट का लेवल यहाँ तक होगा तो ये तो स्पॉट सॉल्वेंट में डिसॉल्व होकर नीचे लिक्विड में ड्रेन हो जाएगा, तो ये इस पे ऊपर कैसे ट्रेवल कर सकेगा?
ओके सर.
That's why we
And
keep the solvent level below. So when the solvent soak up the water paper, the whole spot travel along, and the components which have a different solubilities get separated with each other.
सर कैन यू से कि कैपिलरी एक्शन की वजह से ऊपर जा रहा है वाटर के साथ?
No, dissolve. It's just solubility. It's not a chemical reaction.
ओके सर.
Okay. Another reason that examiner may ask, for example, examiner can show you a diagram like this. If you see in this diagram, the whole setup is covered by the lid. And here, if you see this, this isn't covered, right? So, why it is covered?
Sir, we are seeing gases.
So, why we are not covering this one?
बिकॉज ऑफ इथेनॉल.
Because of?
Ethanol, organic
What
compound.
ethanol do?
It evaporates.
Okay, very good. Ethanol have a low boiling point, so ethanol evaporates like other organic substances. Like if you keep the petrol, what will happen? It evaporates readily, right? So ethanol also evaporates. So that's why we kept the lid over here. So examiner asks you this thing by 2 ways. One thing, examiner will ask why this lid is put it over here, and examiner didn't mention the solvent, so you have to identify that the lid is over here because the solvent must be ethanol, which can be evaporated. That's why we have to cover it. Sir, so there is no need to cover it with the lid. So the other way examiner asks this question, examiner will mention the solvent. Instead of solvent, examiner will mention over here ethanol, and then examiner didn't kept this cover over here and ask you to identify the mistake. So you have to know this thing, that if there is a ethanol, ethanol can be readily evaporated, so there must be cover. But if there is a water, there is no need of placing the cover. Is this clear? Okay. Besides this, we have discussed earlier that we use, uh, for amino acids, we do the same thing, but amino acids are what colorless. So if you put a spot over here, the spot would be the colorless, and after the whole chromatography is done, you are not going to observe any single spot over here. So how we will identify that how many amino acids are separated? What we spray? Yeah, we spray some. We call it locating agent. So after the chromatography is performed, here I have just mentioned this. Locating agent is sprayed, and as the locating agent gets in contact with the paper, on the places where there are amino acids, we are going to observe some colored spots. Is this clear?
Yes, sir.
Okay. So here we are done with all of the, experimental chemistry. Now let me see if we have a question specifically from chromatography. So we will read those. All right. This whole file is clear. Solvent trend is this. From till where the solvent is traveled. From the baseline till this, that is the solvent front.
सर मैंने वैसे हॉरिजॉन्टली शिफ्ट क्या कहते हैं वैल्यू निकालने की वजह से आपने जो आपने अभी बताया था कि फॉर्म पे यूज करते हैं
Sorry,
जो आपने फॉर्मूला बताया था उससे हॉरिजॉन्टली हमको क्या कहते हैं
vertically
वर्टिकली
we have to calculate the distance.
सर आपने फाइल कहाँ शेयर किया है
Group में
सर मेरे पास ये आएगी इसमें करने के लिए
आप कब से ऐड हुए हैं?
सर इससे आप देखिए
कब भेजिए मैंने फाइल? मैं तो शीट ही सेंड करता हूँ अभी अभी तक.
एक्सक्यूज मी सर.
Yes.
सर आपने बताया कि हम जो प्लांट्स के अंदर सैंड डाल के फिर ग्राइंड करते हैं, तो सैंड का क्या पर्पस होता है?
Plants में actually we place that sand in the pestle where we are grinding. So the sand provides a rough surface, so it will be easily grinded. And the
Okay.
pigments are easily extracted and dissolved in the ethanol.
Okay, sir.
Questions? Okay, now have a look at these questions. In the last class, we did fractional distillation, introduced chromatography. Okay. So look over here. A student separated two alkanes, hexane with a boiling point of 69 degrees Celsius and heptane with a boiling point of 98 degrees Celsius using the apparatus shown below. So if you see, this is the thing. So if there is this, so it's a fractional distillation or distillation? Fractional
Fractional.
distillation. Okay. Name the piece of the apparatus labeled M. So what we call labeled this M?
Fractionating column.
Fractionating column. Very good. It's fractionating column. Now, what is it used for? Yes, to separate
Elements.
Yes, to separate what? If you will just try to separate, you will not get any mark. What moves over there?
To separate the liquid which has a lower
Liquids
boiling
or
point.
vapors? Because the liquids are getting evaporized and then travel over there. So to separate, you can either write liquids or vapors. Name the piece of apparatus labeled N.
Condenser.
Condenser.
Sir, what do you mean by papers? Some meanings that say that.
You can write any one, not both. Either you can write to separate liquids or either you can write to separate vapors. Both are acceptable, but if you write to separate substance, it doesn't make sense. Over here, why? We are using these two terms because what we are separating? Liquids. But when they reaches over here, they reaches in the form of vapors. So both either vapors or liquid, any one. Okay. What it is used for? Yes, Manahi, can you tell me why we use condenser? Why this is used? Yes,
To cool down
to cool down
the vapors.
the vapors or to turn the vapors into
Liquid.
liquid. Basically, that is the actual purpose, that the vapors gets cooled down and as a result, the vapors turns into liquid. To turn vapors into liquid. Why was hot water bath used rather than a flame for heating the mixture? See, they are saying that there is no flame used over here.
Sir, what about the series के अलग है temperature constant sir?
Sir, the mixture is flammable, that's why.
Yes. Can you repeat, Khadija?
The mixture is flammable, that's why.
Mixture is flammable, hexane and heptane. These are the constituents of petrol, the hydrocarbons, which are highly flammable things. So that's why we can't use the flame because they catches fire. So the mixture is flammable. What was the reading on the thermometer when first few drops of distillate appeared in the beaker? Read the question again. What was the reading on the thermometer when the first few drops of distillate appeared in the beaker? It means when you are going to get the liquid over here first time, then what is the reading over here?
The boiling point पे depend करता है ना.
Yes.
10 K.
So they have provided you the boiling point. So first, the one having a lower boiling point will, separate it first. So the thermometer have a reading of 69 degrees.
Sir, we expecting a constant was
No. If you have to mention this, if you are not mentioning the temperature, because see, what was the reading? They are not asking that how temperature is changing, whether temperature is changing or not. They are not asking that, right? Read it again. How did the student know all when all the first alkene had distilled over?
Temperature changes on
When the thermometer start, what happens?
So then when the temperature started increasing.
Yeah, when the temperature start increasing, when all of the one of the liquid is collected over here, what will happen? That the thermometer start rising up. So
the change.
no, change means it can be dropped. So that is an ambiguous answer, and examiner doesn't accept the ambiguous answer.
So it is only 69 Celsius, one answer.
Yeah. Start rising. Is this clear? Okay. Now we have discussed all of these except I think one. All of these apparatuses are discussed. Answer each question by writing in the table below the letter of the piece of apparatus most suitable for the purposes. And I have discussed the purposes with you guys as well. Okay. Helping to pour a liquid into a container with a narrow neck.
F
No.
P
No.
E
D.
Why we use funnel?
So that is liquid.
And where when the neck is the apparatus is narrow, where we are adding it, so we will always use a funnel, right?
the washing. I thought it was for measuring the.
See, read the question again. It's D. As a titrating flask, so what is titrating flask? B, it's a conical flask. Conical flask I have mentioned over there in the set of the apparatuses. If you see, conical flask is used as a is used in No, you have to identify these. See? Which one is used as a titrating flask? So it's B. Transferring 80 centimeter cube of a liquid into a container.
F E
E or F?
C
E.
Look at the scale of F data. How much you can measure from F? 50. And you have to measure it 80. So it's E. Is this understandable?
सर हमने इसमें तो कौन सा दिया
Funnel. I didn't discuss funnel, but in the filtration you already have seen and you all know what is the purpose of the funnel.
Titration with
In titration we use the flask. In the flask there is a one thing, and in the other chemical, the other substance is in the burette. And when we then after we add the other substance from the burette in the flask while shaking the flask, we have discussed the whole process in the salt preparation. Okay. What is this?
Pipette.
Pipette. What safety item should we use with this apparatus?
gloves
No.
Bulb. Sorry.
Safety apparatus, safety item. Check your notes, please. Pipette, what we use? Safety bulb. Yes, see, we have discussed this thing. We use safety bulb. I have told you, if you recall, if you have to fill this, it will work as a straw. And we are normally using it with the chemicals like bases and acids. So if you will fill it like the straw, so there is a high chance that some of the liquid, some of the chemical can enter our mouth. So beside this, we use safety valve to fill it. To prevent liquid entering mouth, that's why we use it. Otherwise, you have to fill it using your mouth. Okay. What is the volume to the nearest centimeter cube of the liquid in this measuring cylinder? 24. Now see this. That is the result of the chromatography. When the chromatography is performed, there are so many different spots.
But also have mixed.
There are two mixtures. See, one spot is placed over here, one is here, one is here, one, and one. If you look at these four, these are single substances because in each of them you are getting one spot. And if you look at X and Y, these are mixtures. Is this clear?
Yes, sir.
See, in X you are getting two spots. So it means that the spot that we have placed initially is made up of these two spots. Because when the solvent travels from bottom till the top, see here they have mentioned solvent front. So it dissolves these spots along and travel, and as a result, if there are more than one component, so they get separated. That's what happened in the chromatography. Okay. Now, what is the name given to this type of experiment? Chromatography. Draw a line on the diagram to show the solvent level at the beginning of the experiment. So where the solvent level is at the beginning of the experiment? You have to draw a
Before
line.
the
Start line say? No, solvent level would always be lower than this, right? When we dip it, we have discussed when we dip it, we keep the level of the solvent below the pencil line where we place the spots. Hmm. Yeah. These, the four on the left. These are impure. Yeah. So this is okay. A pencil was used to draw the start line. See here, instead of baseline, they have used the term start line, and they have asked you a pencil. Why was a pen not be used for this purpose?
It's all in the hot air.
It dissolves and it have a different colors, right? The ink is made up of different colors. Use the diagram to deduce which of the substances were present in mixture X. Okay, so look over here. If we talk about X, X is a mixture and Y is also a mixture. Yes, Aisha, what you were saying? Okay, see, yes, if you look at X, there is a one spot in X is over here, which is exactly the same distance as S. So it means that the mixture X has a one pure substance S in it, and the other spot is having the same distance as U. So it means the other substance that is present in mixture X is U. So you have to identify like this. So I will write over here S and U are present in mixture X. Now let's have a look at mixture Y. Mixture Y have S, R, and T. Very good. So S, R, and T, these three things are present in mixture S, R, and T. Now see, using a ruler to measure the distance traveled by the substance T and the solvent front, calculate the RF value of T. So see, in exam you will use the ruler. It's 4, right? See, The distance traveled by T is
5.4.
how 5.4? 4, it's 4. Where is 5.4? It's 4. And if you look at the solvent front is 5 point,
5.
it's 5.5. Let me zoom in. It's not sure. See, it's 5.5. Okay, so in the same way you will do it with your ruler. So solvent front is 5.5, it is 4. So RF value will be 4 over 5.5.
5.5 measures fully.
5.5 is the distance traveled by the solvent, so which is always in the denominator, and the distance traveled by the substance is in the numerator. So what is the answer?
0.7.
0.72.
7.
Okay, so it will be 0.73. Is this clear to all of you?
Yes, sir.
It's round off करने जरूरी होते हैं 7.
You can write 7.27 as well. But if you will just write 0.72, so examiner might deduct the marks. Okay.
There are minor centimeters potential for that. Say, major.
Marking getting you. Okay, now have a look over here. Which of the measuring cylinders show exactly 20 centimeter cube of a liquid?
Say in
No B,
A.
only A.
C.
See the scale. Okay. At which point is the temperature 100 degrees Celsius? The diagram below shows the apparatus used to distill seawater. At which point is the temperature 100 degrees Celsius?
So my X Y
Why Z? Z have a lower temperature because it condenses. So Z is not the option.
Why only?
Why? Why? Because X we are getting continuous heat, so it is not 100. It gets greater than 100, but here it stays. No, in both the places it stays 100 until all the liquid evaporates. So it would be X and Y. So you know its name. It is what? Pipette. Burette have a tap. It is a pipette where we use the safety valve. Okay, now read this question and who is going to tell me the answer? So
Second answer is
that is some other experiment. Okay, you didn't do this experiment yet. There are two types of things where we are using the condenser in the fractional distillation, that is for the separation. Here there is a chemical reaction taking place for which we use the condenser in this way only. Yeah.
Sir, water entrance is in the wrong way.
Yeah, in this the water's movement is actually the wrong way. In this, water is moved from here and goes out from here. In this, when we remember, whenever the condenser is placed vertically, the movement of water is like this. Okay, from downward to upward. The movement of water is always like this. In that, The condenser is placed like this. And if you recall the water movement, water is entering over here and getting out from here. So it is again moving in the upward direction. So here they are moving the water in the downward direction. The water always moves
From down to up.
from down to up. Okay. Okay. I'm going to share the whole file. There are so many other questions as well for you guys to attempt. Okay. Do practice it, and in the next class, are we done with the atmospheric chemistry, air and environment? Okay. So in the next class, we will do that.
So the team that
Yeah, tomorrow
yeah,
I will be here. And if anyone want to come, do come. And if not, then you can join online as well. Okay, but just keep a margin of 5 minutes. Do not come before 3 because there might be a coaching will be closed before 3. It will usually going to open at 3. So come at 3 or at 3:05.
Sir.
Okay. Take care, everyone. Allah Hafiz.